I'm going to present some research data that we collected. Tim is involved there, Richard Ferguson, and Aaron Stockton at UNL. Okay. So I'll be talking mostly about soil physical properties, but I'm looking at this from an integrated perspective. So I'll be mentioning crop yields and organic matter particularly, okay? This is going to take about 1 second, right? We know about the many uses that crop residues have, right? You know, we need for livestock, obviously, right? And for cellulosic ethanol, that topic's not going away, I guess, right? So there's still a potential for that. There might be some commercial, cellulosic ethanol plants opening up soon, right? So we still have to think about the use of crop residues for that as well. And well, what about for the soil, right? If we just harvest corn for silage and everything, the cows will eat everything. Well, there might be not much left for the soil, right? So, and obviously, we have the still residues. This was I took this picture last fall. I'm working with a producer south of Columbus, and he baled that. It was a week after he baled, so there's not much residue left there. Okay, so we talk a lot about soil health, right? Soil quality. So we need to think, obviously, about how to take care of the soil, and you know a lot about what the benefit of the soil is for the crop. So I'm just preaching to the choir here. Anyway, just this is something, just a reminder for all of us. This is the pre-cultivation, right? Like 100 years ago or more, right? That's where the level of organic matter was. Organic carbon was there, right? Okay. Then modern agriculture came, right? Then what? It dropped. Organic matter content dropped, right? Now probably we're here. Okay. We're here, and now if we keep plowing it, and plus if we remove residues, we're going to reduce more probably organic matter content. Okay, right? And actually we should be doing all the opposite, right? Probably increasing, obviously some of you have done already, no-till, using no-till, probably some cover crops, and, take 1, take 2, take 3, right? So that's the goal. But we are probably at the, around here now. And that just gives us that we lost about probably 40 or 50% of organic carbon, right? So with intensive cultivation. And we need to consider that when we talk about residues, because residues have what? About 50% of C, right? If we analyze, and also if it has nutrients, okay? So we have a lot of questions. A lot of speakers covered this already this morning, right? Tim explained about water infiltration, bulk density, and those are soil physical properties, obviously. Okay. Then we have erosion. I'll spend a lot of time on that. Wind erosion, water erosion, right? And then with organic matter content and yield. Why do we have to talk about, like soil aggregation, aggregate strength? We talk a lot about those basic soil properties as soil physicists, but what's the use, So we have to integrate that with yields, and that's what I've been doing, or trying to do. Okay. I'll be honest here. Most of us. I went to school at MU with my master's and PhD degrees in Western Missouri. Then I moved to Ohio, and I worked there for Ohio State for 5 years. Then at K-State, I was there for about 5 years. I always did research. Not always, probably, but most of the time I did research in the small plots. Okay, small plots like 20 feet by 20 feet, or 30 by 30 feet. And now there is more emphasis on large scale stuff, and producers' fields. I guess that we need that type of data. So Aaron Stockton is going to talk more about the on-farm projects that we have. I'm also involved with some other researchers at UNL and the eastern part of the state. So we need this from producers' field, large scale data. Okay, so we don't have a lot of information on soil physical properties, after grazing, baling, right? And so we need more data. Then even we can use some models, for the whole state. And I mean, we already know this. I mean, does baling affect soil properties more than grazing? Probably, right? Because grazing. I mean, grazing. I grew up in the highlands of Bolivia, and I grew up in a farm, and my parents. I mean, they used to, just graze and residues. I mean, that's nothing new, right? So the thing is, you manage, right? If you graze, let's say, all year round, you will see the negative effects. So it's rotational grazing and timing obviously is important. Okay, and when we graze, I mean, there's a report out there, right? When we graze, we don't remove everything, right? Probably not more than 20%. So it depends on the stocking rate, right? Okay. Wind erosion, I mean, that picture I've seen probably many times, right? I mean, from the 1930s. And then just, well, is that gone? Well, it's gone, but we're still, I mean, we still have issues with erosion, I think, right? Okay, especially during dry years. So we have to keep that in mind. Okay, so we have looked at soil physical properties that affect wind erosion. Where? Here at Brew, okay? With other researchers and Tim Shaver is involved here, Alan Stalker and others, and so there's a nice experiment there. Tim mentioned about that, so we have baling, heavy grazing, no removal, and late grazing, the whole center pivot, right? Okay, so what I did is I collected some samples last spring, okay? So I sent those samples to Manhattan, Kansas. I'm going to have one of those devices soon at UNL. I moved from K-State to UNL in July 2012, so I'm still trying to equip my soil physics lab. So, but anyway, I work with USDA scientists down there in the wind erosion unit, and what it does, we just put your soil sample in here, and it separates, right? Then just collect a pan of soil carefully from each plot, and then you put it, place it there, and then it will separate, and it tells you, well, how soil aggregate properties, change in their different management systems. In this case, it's, baling and grazing, okay? There you go. So, for aggregate size, the size of aggregate depends, right? If the aggregates are large, soil will be, resistant to erosion, right? So it's going to be less susceptible to erosion if aggregates are large. So here you go. We have no removal, right? Business as usual. Then this is extreme, right? Baling probably. And the cover, this was provided by Simon Van Dijk, a researcher that was involved in this project. There are no statistical differences there. Okay, there is a large variation, standard deviation there. Okay, but there is a trend there, right? Aggregate size, soil aggregates seem to be smaller when we bale all the residues, right? It's important to remember that there is a trend there, right? What about the fraction? These are the small aggregates, right? Any aggregate that has a diameter less than 0.84 millimeter is highly susceptible to erosion. Okay, so this has been defined early in the 1930s by Chapil, after the Dust Bowl, and they studied this a lot. And here again, so let's look at on that fraction. Well, when we remove everything, not everything in this case, I guess in this amount we removed, but I guess about 60%. I mean, Tim can confirm that. So about 60% of stubble produced. Again, there is a trend there that there are no statistical differences. So this kind of supports what Tim was talking about, the bulk density, right? For the same experiment, there are no significant differences there, but there is, it seems that the negative effects may show up significantly in the future. But there is a trend there, right? It's increasing. Okay, for soil susceptibility to erosion. What about water stable aggregates? That's important for not only for water erosion, but nutrient cycling, because for organic matter content accumulation, things like that. And then the same thing, this kind of a slight, not statistically significant, but kind of slight decrease if you bear, right? And not much with grazing. And also organic matter, the same thing. There's a small trend there again, right? This is important, this organic matter, related to organic matter. nutrient. So I don't think we see a lot of negative effects after this is what, after 4 years came. This bill was established in 2009, right? 2008. So it's like after 5 years. Okay, 5 years. So we don't have, we did not collect this every year, so but we're going to monitor this more. Although organic data may be available there, but this is some reporting data after 5 years. Okay. Just a slide that Simon Van Dok shared with me last year. I talked a lot about that, right? I mean, we know that residue is important for trapping snow. And then he said that, when we bale and the residue covers only 60%, what happened? We lost a lot of water there, right? Like 5 inches, right? Okay. Another hydrologist and irrigation engineer, but that's clear there that if we remove everything, we are losing water there, right? So important to consider that. Okay. What about yield? For that site, can you correct me if I'm wrong, Aaron? I don't think there was no difference in yield. Okay, that's what I was told. And then in 2012, this is not probably very high. It's an irrigated, system, but not too low either, I would say. And then about 60% of residue was removed. Okay, so that's bale. So 60% was bale. So that's I would say it's more than what has been done in other places. Okay. Now more data. Okay, more research data. This is from Clyde Center, east of Hastings. Okay. It would take me a while to explain, but I'll try my best. Okay, it's a complex experiment. The split plot design. We have 4 replications. Okay, we have full and deficit irrigation. This is ET, but this is just full irrigation, and then limited irrigation. Then we have this is an experiment that Richard Ferguson, soil fertility specialist at UNL, established in 2010, I think. So the treatment, we have first the split is cover crop, winter dry, then manure, okay, animal manure, then control. I guess manure was applied about 10 tons per acre, okay, and then control. And then we have 2 removal rates there. So pay attention to this. 0 is obviously control, no removal. Then 63% removal, average after. So this is a 3-year experiment. I'm reporting results after 3 years. So the first year was like removed, like 65, I think. The second year, like 76 or something. Then and less the third year. So the average is 63% across 3 years. So about 3 tons of stubble, right? Okay. And we have 2 fertilization levels there. Okay. So complex experiment. And here are the findings. So this, we have. Look at this though. This picture before I forget. This doesn't look like 63% removal to me. Spring, right? We removed that in October of it after harvest, but this is how it looked last March, a year ago. Right? It's like 100% removal. So residue was gone. Okay? And we still have cover. I guess I took this picture 1 week after killing cover crops. So the cover crops are about to die there. Okay? Anyway, so here you go. Just showing the slides about how we collected soil samples in detail from different depths. We look at obviously, if you have residues, I mean the soil is its water content is going to be higher than if you don't have residue cover. Look at a lot of cracking, surface sealing, things like that. And at first somebody asked me about this. Oh, this is an extreme case. This soil is just bare. Well, I said. It's not, there are some producers that do that. And I am working with a farmer near Nebraska City. And he even bales soybean, soybean residues. So, and this is how it looks like this in some areas. Obviously, he bales in strips, so, and he's proud. But in some spots, it's like this. So it's not very uncommon to see that. Okay? But if you have cover crops, obviously it will protect the soil more. So we collected soil samples at different depths, we had these rains, and look at what happened after 3 years, okay? And then I made this shaker or whatever in the lab. That's just a mechanical device to sieve soil samples and water. And look at this. This is no removal, okay, control, no residue removal, and this one is 63. I put it here 85. This was for only 1 year, was 85. So anyway, this should have been 63. Look at that after 3 years. You know, aggregates. There are more aggregates, obviously large aggregates, when you don't remove. And if you remove 63% average across 3 years, in this case, you don't have any large aggregates left there. Okay. And then what about now if you add cover crop? You know, this is kind of an interesting study because we are adding cover crop and manure to offset, right, the negative effects. You know, to and then well, this is 63% removal, and then with cover crops, okay. And this is different, significantly different than that, but still it's not that bad, right? Because look at this. I mean, what about now if you have if you add manure? Cover crops have more benefits than manure, right? You can see it. So this is control, and this is after removal with cover crops, and this is after removal with manure, right? And this looks like just removal. So manure is not helping. So it might work in the future, but this is only short-term data, 3 years, right? But cover crops seem to be improving. Okay, soil aggregation because of the roots and protects the soil more. So okay, so just this data they're looking at in graphs, the same thing. In terms of organic carbon, they are looking at just the upper 1 inch. That's important for, especially for erosion, water infiltration, because if there is like surface crusting, sealing, the closure of pores, micropores near the surface will delay water infiltration. There will be more erosion. Although in this field it's flat, but there are other cases, and we can lose water through erosion. So we looked at this near surface changes. Okay, the organic matter. Look at that. So there was a significant decrease there. This is small letter means that AB, but in the upper 1 inch. Okay, but and then one thing to remember is this. This is the main story from this. So when we removed 63% average across 3 years, there was a decrease in organic matter content in the upper 1 inch, and that's important. Probably not a lot for cover crops, but for some water infiltration, things like that. But what happened now with cover crops? We added cover crops, right? So remember this, right? So this is no removal, business as usual, right? Then we removed, then we removed, and we added cover crops after removing, right? So this big letters A and A are the same, so that means that there are no statistical differences. So what does this mean? That means that cover crops offset, right, the negative effects. There's small negative effects, right? So cover crops in this case work for aggregate stability. It worked. So, but it's, again, we're looking at the shallow layers. So we see the beneficial effects there of cover crop. What about for water? This is not water, the actual amount of water. Like we collect soil samples sometimes, we put it in the oven, and then we get we call this the gravimetric water content. This is the water retention, the ability of the soil to hold water. So we use pressure extractors, and again for the surface 2 inches, we see a decrease then in the ability of the soil to retain water. Okay, and look at that. So first, no removal. No removal is 0.37 at this pressure, and then what happened when we removed? We removed this 85%. Again, this was 1 year, 63. That's the actual amount across 3 years. And look at that, the 0.28. So it decreased, right? So it seems that when we remove residues, we are reducing the soil's ability to retain or to hold water. Okay? So, but not below 2 inches. So somebody may say, well, 2 inches just fluctuates a lot, right? So we need to monitor this probably in the long term, okay? So it's only on upper 2 inches. Below that, there were no significant effects removal. Okay? Water infiltration, short story from this slide. No differences in water infiltration, okay? Even though there were changes, right, in aggregate stability, there was a drop with removal, but there was no difference in water infiltration. You know what? Here, initial infiltration at the beginning Actually, water tended to infiltrate it much quicker when we remove residues. You know why? Because the soil is drier, right? The soil is dried at the beginning, so and we use this double ringing filtrometer in the field, and the water infiltrated much quicker at the beginning. But you know, when we measured for 2 hours, I think, or 3 hours, it was like 2 hours for this case, but there were no differences in cumulative infiltration, so that's good news. Okay. So erosion potential. This was a picture that took one of those days when I was out in the field. It was like this. You know, this is a plot without stover cover. I mean, little stover cover, right? Huge effects on wind erosion, though. So that's the main historic product from this work. That we found large and significant negative effects of residue removal. Okay. So not even cover crops helped. Manure, nothing. So I don't think cover crops will help much if we remove a lot of residues. If the surface condition is like this, right? Looks like this. So they don't help much. But I guess cover crops were useful for controlling, you know, the wet aggregate stability, you know, organic matter, things like that, at offset, but not for wind erosion, right? So to remember that. Just want to share with you, I worked at K-State for many years, and we had similar sites there. And I had one in eastern part, Arawa, one in Colby, just south of here, right? And then in Hugatan, okay? And we looked at this on the irrigated and rain-fed, no-till soils, similar study. And organic matter again, soil carbon. What happened after 2 years? We measured in the upper 2 inches. There was nothing. No differences in organic matter content. This is Colby, right? Okay. No differences in organic matter content after 3 years in the upper 2 inches. What about in Hugatan? The same thing, nothing. So looking at here the pool in tons per hectare and eastern. What about an eastern and rain-fed? These two are irrigated, right? Irrigated, and this one is rain-fed. You can see a decrease there. Look at that. So there is a decrease in organic matter content of carbon here when we remove everything. So under rain-fed conditions, probably we'll see some negative effects. And in Colby, I guess it was in 2010, we got 300 bushels of corn. So that was a good year. So there was a lot of residue there. So it depends on the year, but after 2 years we didn't see any negative effects on organic matter content. Okay? What about yield? What about yield? When we removed residues, this in Colby, when we removed everything, this was a small plot, actually the yield increased a bit. Right? Bushels. Look at that. Well, another bit, a lot actually, right? From 2.8, so it increased. But what about another irrigated site? This is just near Garden City, in Hugatan, right? No differences, right? But what about rain-fed condition in eastern Kansas? Similar, huh? So I was a little bit surprised about this, but I guess because Charlie Workman mentioned earlier about temperature has an effect there, right? When we remove residues, the soil will warm up much quicker in the spring, so that helps. When I was in Ohio, I used to measure in the height of the the seedlings and things like that, and monitor, and that has temperature has a lot of effect. Okay, so depends on the site. It's site specific. We cannot generalize this, but something is going on here. Here there's an increase, but here it seems that there is no effect. This is a sandy loam. If you remember that, okay. This is sandy loam, sandy soil, silt loam, and silt loam. Okay. Temperature. Okay, so we had sensors installed in each plot, and a lot of fluctuation in temperature when we remove residues. Look at this. Here we have 100%. This is the solid line, right? 100% removal, the solid line. There is the solid line, right? Okay. And what about no removal? No removal is there. So the dotted line. So you can see clearly that when you remove residues, you increase the temperature fluctuations. There are more peaks, right? Here you go, high peak, remove everything, and then, right? So keep that in mind, that temperature soil changes a lot with residue removal, and that could be important in the long term for crop production and even for soil aggregation, wind erosion, a lot of things are affected by temperature. Temperature is important. We don't talk about this much about a lot of times, and I'm going to do more work on this. It's like when you go to see a doctor, the first time doctor will measure temperature, right? So it's critical. It's up to that you have more research on this, how these fluctuations are affecting crop production. Okay? Just borrow this slide from Brian Winhold here. I should put his name down in larger letters here, but anyway, Brian Winhold with USDA did a nice study of water erosion, New York, right, west of Lincoln, and then he found that if you remove residues, right, we lost but how much did he remove? Well, it was like removed about need 3 tons per acre. Okay, so he removed, and then there was more sediment loss. Okay, so it's important to remember that it depends on what type of soil. If it's sloping soil, and if you remove residues, it can increase erosion. Okay. Well, the question is now, how much should I remove? Well, it depends on the tillage system. Like, if in order to maintain organic matter, you need more residues than to reduce wind erosion. Important to remember that. You need more residue to maintain organic matter content than to control erosion. That's what Wally Wilhelm, he passed away a couple of years ago, wrote a nice paper and found out that he did some modeling work there. Okay, how much should I remove? Well, depends on the tillage again. Well, you have to leave more. If you're still using more work plow, obviously in a very deep still conventional till, let's say conventional till, you need more residues, right? You have to leave more residues than if you are using no-till, conservation tillage. Okay, and also depends on the cropping system. So that gets complicated. So if you're interested more in this, please email me, or just can provide more details about the rates and again here, if you are producing probably like 200 bushels right per acre, you may be safe. You can remove probably. But what about if you are at this end, low production? We may not need to remove. Okay, so this gets complicated depending on the tillage system, right? Okay, so around this area might be okay, above 200, right? About they can remove some. Well, how much? I'll provide some estimates later. Okay. 2 more minutes. Do I still have time, or do you have anything? Quick. Okay, good. Thanks, Taylor. Well, I know that there's a lot of interest in cover crops. So I've done some work, so I would like to share that with you, okay? I've done some work on soil properties, looking at different types of cover crops. I'm not a crop scientist, but I'm trying to work across borders, right? So I can understand the system better. Anyway, this picture is taken near Heston, north of Wichita, Kansas. These are taken the south of Columbus. I guess I was at that site with Charlie Workman. We took these pictures together, I think. You're familiar probably with this report that came out with the SARI, that's this North Central Sustainable Ag, with USDA and the CTIC. They did a nice research. This gives you a kind of broad idea, right, about cover crop, cover crop studies, or how cover crops work, in the states, in this region, right? So Nebraska is obviously there, okay? And then we have, obviously, the acreage. The acreage under cover crops has increased, right, a lot recently, right? From 2008 to 2013, okay? I have a couple of slides about that. Well, what cover crop should I use? What do you recommend? Well, most of the farmers are using what? Winter cereal grains. Winter rye obviously is there. Okay, we used winter triticale in western Kansas. I have a slide or two. Brassica probably, Brassica legumes obviously. and mixtures, cocktails, right? So what species should I plant? What to plant depends on your goal. Okay? Depends on what you want to do with the cover crops. Are you trying to just protect the soil, or are you trying to, grow for animals? So it depends on that goal. And if you want to add nitrogen, if you want to increase soil fertility, so you might want to put some legumes, right? But if you just want to cover soil, and then probably just from wind erosion, so maybe winter cereal grains might be a good choice, right? Okay. This survey said that okay, cover crops and match no-till, right? If you use cover crops, try to use a conservation tillage, because if you use conventional till, you're just mixing that residues, crop residues with soil, right? And then you're burning, right? So you're like stirring a fireplace. So you're burning most of the residues, no benefits probably. Okay? What's the biggest challenge? We already know that, right? Establishment, right? And obviously cost, right? Time and labor. Well, what species should I use? What about the cost, right? So it reflects what producers are saying there, right? So establishment, so we need to know how to manage. When should I kill? Early termination, late termination, how long before planting the main crop, things like that, okay? How much does it cost? Well, median seed cost in Nebraska about $30, right? $30, right? And what about how much does it cost to establish cover crops? Here is Nebraska again, $15 or $20. Depends how you establish, right? We established a cover crop experiment near Bearwood, south of Columbus, with an airplane. This is not the picture I have. This is from a picture from eastern part of the United States. But we did put cover crops. We planted before harvesting corn. Okay, so that's one way of doing it. You can also drill, right? So, okay. Well, you know what? What about yield? I mean, that's always I get that question. In Nebraska, according to that survey, they said actually, if you had some cover crops, it can increase yield. Okay, so I guess it depends on the year, depends on specifically where, what the value is, that part, right? And it says increased yield. Okay. And if you don't have any cover crop, you see the red, so you increase yield by what? By like 15 bushels, right? Okay? But there's not much there though. This is dry land probably, right? Okay? Opportunities, like Charlie Wortman said this morning, there are a lot of opportunities there for cover crops, and we are already using cover crops. Depends on the goal, okay? What species should I plant, right? And how to plant, right? When to terminate, and that's an excellent. I've been asked that question. When should I terminate, right? Well, if we know that's going to rain next month, then you can terminate 1 month before. But I mean to terminate long before that, But it has to be definitely several months before you plant the next crop. Okay. We have started work at Mead with scientists from animal science, and stay tuned. I will have more data. I hope Tyler brings me back next year in the future so we can throw more data from fields.
If they want you back.
Yeah, exactly. Yeah, you guys actually. Yeah. So we're going to have field data. I mean, more from long-term, from large, plots, and to looking at not only soil physical properties but yields as well. Okay. Just wanted to share with you, I guess, Charlie Wortman mentioned from Garden Series this morning. We did some work with John Holman. We were trying to replace fallow with cover crops. So this is a wheat fallow system, no-till wheat fallow. So we're trying to replace, we're trying to grow cover crops during fallow. And that's what, he was the leader in this, but that's what he did. And he even hayed cover crops. Okay, he hayed cover crops, so this is the amount of precipitation down there. He was haying every year. And you know what? We hayed that. There were no negative effects of haying on wind erosion after 5 years. So I guess that's good news. So I mean, there is some, again, some trend, right, higher, but statistically there's, large letters, capital letters, AA for organic matter, and when there are, I mean, there were no statistical differences there. So I think that's good news, The cover crops can be, because if there is no economic, benefit, I don't think cover crops will be very attractive. Okay, this from the same site. Well, it depends on the species, right? We were successful with triticale. Spring triticale, we were about 4,000 pounds, right? But like winter pea, spring, hairy, rich, and yielded very low. Okay. Just let me know if you are not interested in that data. But the short story is that hay did not affect soil properties down there. Okay. I don't know what happened with that side, but this is from Wichita. Mentioned about that near Wichita, Heston. We had summer crop. This is a wheat sorghum, so we put cover crops after wheat. That really works because we have more, growing, period, from July until October or so. And look at the sun hemp, right? And then off-season soybean, and then you have look at even the soil aggregate, the color changes, right? When you have cover crops, it's much darker, right? The aggregates are darker. And look at the organic matter content here, or soil organic carbon increased with cover crops. This is after 15 years though. We saw a lot of benefits from cover crops here. It's because this is a long-term study, so that's why we have to be patient, I think. We have to walk before we run, right? So look at that. I mean, it's a good increase. The same thing with nitrogen. And I have more data there. Look at that. I was counting number of earthworms because that affects water infiltration. So you counted earthworms. Look at that. Don't have cover crops. They're just no-till. This is no-till, okay? No-till. But this is the second step now. Technology 2, right? You're adding cover crops. And what happened? You increase the number of earthworms, right? And then depends on the gain. If you use like sun hemp, has been very good. It increased a lot of increased the earthworm population. And if you increase the number of earthworms, obviously you're creating more channels, earthworm channels, and then you increase water infiltration. Right? So higher water infiltration with cover crops. And aggregate stability, the same thing, and that's because of organic matter content, things like that. Okay? So a lot of changes, but after 15 years. Okay? And here you can see these ones have cover crops, right? I mean, the soil surface is darker, but if you don't have cover crops, right? So, long-term study. What about yield? An important to this is grain sorghum. I apologize for a small font here, but grain sorghum yield, and this is wheat yield here. And what's here? Down here is nitrogen rate. We had 4 levels of nitrogen: 0, 30, 60, 90 pounds per acre of nitrogen. And the red one is no cover crop, and these are with cover crop. What happened? It seems that cover crops work better when we don't have when we don't apply a lot of inorganic fertilizer, right? Because when you apply a lot of inorganic fertilizer, we don't see a lot of benefits. And the kind of the same thing with wheat. Okay. Well. I'm going to go quick through this. As I mentioned earlier, I think we can graze cover crops. It depends on how long. We don't have a lot of field data, but this has been done. It's nothing new, but I think this would be good for not only for producers, but also for the soil. You know why I'm saying this? Because root cover crops leave a lot of roots, increase root biomass, and that's it's a win-win case. Okay. It's not like adding manure, right? When you add manure, it's just, transferring from one point to another, right? From one spot to another. But when you grow cover crops, you are improving soil structure through the root, the below ground biomass. Okay? Well, conclusions. This is just probably a rough estimate. I would say if you bale or graze this we don't place that much 50%. If you bear about 50%, you won't see a lot of negative effects on soil physical properties. Okay? But one may say, well, 50% of what? What about if I'm producing, let's say, 10 tons, right? And if 1 year is only 5 tons, so it depends on that. But this is based on the experiments that I shared with you, and that, from those 2 or 3 sites. And so far, this is what I know. Dependence about 50%. Like at Clay Center, we removed what? Average 63%, right? There were negative effects. But now I'm establishing more experiments at different levels. Then we can see what's the amount that we can safely remove, right? So important to know. What about if it's 30%? Although we do not have probably equipment to harvest, any small increments. Anyway, so but it seems that there is increased risk of erosion. We remove more than that. Okay. Although at at Brule, we didn't see a lot of negative effects, but there is a trend there. In the long term, I guess we will see negative effects if we remove more than 50%. Well, cover crops may not help with wind erosion in the short term, right? It can help, but if you remove a lot, like I showed that slide from Clay Center, it looked like that it was 100% removal in the spring, and then you can still lose a lot of soil. Well, this is important, right? Irrigated corn, no negative effects. Actually, we saw some increase depending on the year, right? And yields after baling, about 50% maybe. Okay. I think that's the last slide.